released here. The sphere will come, well, collide here. Now this will be the line of, first let me draw the sphere. Sphere I'll show by this is the line of impact. I think this should be common normal. There's a common normal. Then, so look at this. Just before collision, this will fall and I touch. So it will have here a speed u. And then how the impulses will act here. The impulse on the wedge will, on the sphere will act in this direction. And the impulse on this particular small particle of mass m1 will act in this direction. Will I agree this? And he has given some information. What is that? Some vertical line he has made. It's a small particle, no? Because from here it is being dropped from a I touch. From here it is being dropped here. So from this, what is the distance? R by 2. And we know this is R. So from that we'll define the theta. So what is theta? Sin theta? R by 2 by R. Theta equal to 30 degrees. So now we know this angle. And now what can happen to the ball? How to describe the motion of this? Again, sir, along X, along Y, it's left to you. I'm telling this one, it's left to student. He can take in any way. This is what happens. Now instead of X, Y, I will describe the motion along normal, along, so this is n cap. This is a tangential. With respect to what? With respect to sphere. There's a particle. Particle or small ball. We know theta, so we can manage here. And now after collision, what can happen here? Will be there, will be there. The impulse by the ground will be there. Okay, if you want, I'll show that also. Now you analyze. So how to describe this problem? Shall I conserve momentum along x-axis? Yes, it is conserved. Can I conserve momentum along line of impact? The answer is no. Can I conserve momentum along y-axis? The answer is no, because of impulse by the ground. So I just took tangential and normal also. In this way also you can think on the problem. So after collision, what can happen? After collision, what all can happen? Now, how best we can do this problem here now? How the sphere must move? Sphere must move. In what direction? It must move. I'm using word must. It must move horizontally, no? It must move horizontally. So I'll assume now normal component. So this is Vn and let this be Vt. There's another way of thinking on a problem. Sir, why Vn, Vt? Yes, we can apply like this. Earlier I took V1x, V1y, here Vn and Vt. And this angle is theta. This angle is theta. So can we define anything? Angle here. So this should be theta, and this will be theta. No. Can I conserve momentum along x-axis? S pi x equal to, and moreover, it is a E equal to 0 is telling. Perfectly smooth collision between particle and sphere is perfectly inelastic. E equal to 0 condition given. Can I conserve momentum along x-axis? Yes, I can conserve momentum. What is the initial momentum? 0. Final momentum. M1 Vn sine theta plus M1 Vt cos theta minus M2 V2. How many unknowns are there? Vn, Vt and V2. So one equation about, I need two more equations. What are two more equations from where I should bring? I'll apply quotient of restitution formula, line of impact. Finding very difficult, what you should do, draw a line and show all the resultant velocities. Only I think this, you should resolve here. So writing the formula, E is equal to, so what should be the value of this? This is theta, this is theta. V2 sine theta, and let me define this direction as positive. So V2 sine theta minus that of the particle. Only Vn will come, no? Minus Vn. What about component of Vt? It will be perpendicular to line of impact. Only Vn will come into picture. Divided by, this should be equal to initial velocity. Initial velocity should be u cos theta. And initially the sphere was at rest. And we know E equal to 0. So as E equal to 0, so therefore V2 sine theta plus Vn equal to 0. I think the problem has become very simple, no? Equation 1, equation 2. I need one more equation. Whose help I should take? What is the impulse? How the impulse will act on the sphere, or on the particle, will act along line of impact and along t cap, along tangential direction. This one along the common tangent. Will there be any impulse? No impulse on the particle. So what should happen to the momentum of particle along common tangent? Should be conserved of only particle, not of the system, of only particle. So what is the initial velocity? Along common tangent. Along t cap, it should be equal to m1 u sine theta should be equal to m1 vt. U sine theta equal to vt. And what is u? U should be equal to root of 2gh. So the third equation. Solving 1, 2, 3 will get the required answer. So I think really a student must analyze very random way, no? Along x, along y, along line of impact, along the common tangent. Try to search all possible things. Why I'm giving all this means there are several ways you can analyze the problem, not only one way the book has given. Is it okay? E equal to 0. That's why u cos theta will e equal to 0. Numerator u cos theta to 0 will be u cos 2. So I ended up with this equation. So taking help of all this solving, we'll get the unknown things. What are unknown things? Vn, Vt, and this one. So now what is the speed V1? Just rather than solving, no, try to learn the different methods what I'm trying to show here. But sir, now your task question, sir. Inelastic, will particle will stick to the sphere or not? Because E equal to 0. Two-dimensional collision, it need not to stick. They don't get stuck each other, that one. One-dimensional add-on collision, as they'll stick to each other, equal 0. Two-dimensional collision, though equal to 0, the particle will lose contact. That's what this particular problem is being brought here. I'll take the next concept. Now I discussed without friction. You can introduce the friction where all needed. This is about